Okay, so we're going to basically fill in the details in example 646 here. So let's go back there. Example 646. Here it is. So we're starting with equation 685. That is this guy. Let's write that down. So the divergence of the electric field is charge density over epsilon naught. Okay, so starting with that. So, yeah, so hang on a second. Right. So this is one of Maxwell's equations. In particular, this is the differential form of that Maxwell's equation. And the problem says take a triple integral of both sides and derive this result here. So let's follow the instructions exactly as given. So I'm going to take triple integral of both sides of this equation. Triple integral over a solid R of the left side. And now I'm going to do a triple integral over that same solid R of the right side. Whoops. Okay, so just following the directions. Does that make sense so far? Mm-hmm. Okay. So what can I do now with both sides of this equation? Well, with this side of the equation, triple integral of divergence, well, that screams Gauss's divergence theorem, right? And in fact, what Gauss's divergence theorem says is that a triple integral of divergence gives you boundary flux. So I can rewrite that as flux through the boundary of R of the electric field. So this right here is Gauss's divergence theorem. That's how you get from there to there. Okay. Now let's look at the right-hand side. Well, I can factor out this epsilon naught. That's just a constant, and I'm left with triple integral of charge density. Well, triple integrals of density means you're just accumulating stuff, right? So that's just going to give you the total charge. Of course, this constant sticks along for the ride. So total charge, and that constant is still there. And that's what we were supposed to show. It's this equation right here, electric flux. Yeah, it works out very nicely. And that's why, by the way, the fact that this is such a short connection is why they call these two equations that look kind of different on first glance. These look different. But we call them just two different versions of the same theorem because they're just an immediate conclusion. Each one is an immediate conclusion of the other by way of Gauss's divergence theorem. Yeah. Is everybody happy with that? All right.